All right, so the video for today is gonna be about something cool I found while I was studying for math class. It's not gonna be a super long video because it's just a really quick, I don't know, trick that I like to use when I'm trying to find the curl of a vector, which is basically like the inner rotation of. I'm not gonna go like in full depth of it, of like what a curl of a vector is right now. If, if I need to, I'll make another video about that. But when I was studying, I was like, oh my gosh, this is like, it was just too much. It was kind of hard to remember, especially all the extra formulas that you have to do. And I was like, okay, what's a quick and easy way to be able to remember this or find the curl of a vector quick, especially like on an exam or something like that. The quickest way is, I don't know, it's just like something that I've thought of while I was doing it. I was like, okay, well, how can I make this into like a mnemonic or something like that? But it's just this whole thing right here. This thing. It's a PNNP minus PMMP plus NMMN. It's just that. That's the entire thing. You can use this for any I don't know, example of a curl of a vector. It's pretty cool, pretty simple. You just have to remember in between each letter is going to be that, because the whole thing itself is going to look like this, which is pretty long, so I didn't want to write it out like that. But yeah, that's how it looks like full form. But essentially all this is, you're just taking partial derivatives. So that's why this P and whatever, it just helps you. It's literally just to help you remember. Like, this video is for somebody who is already in calculus 3 or beyond, differential equations or whatever. You're trying to find the curl of a vector and you're like, okay, using the formula is cool, but it's just kind of like hard to remember. This is just something that made sense for my brain, and it worked for me. Because like the full formula will look something like this. Let me erase this really quick. It looks something like this, because you're taking the partials. Parenthesis there. It's kind of cool how it works. Another parenthesis, and then you're gonna minus because the way. Well, okay, you already know this. Obviously, if you're watching this, I can make a full in-depth video about like why you do this, how it relates to divergence of a vector, all that stuff. But basically, the I, J, K, whenever you make that matrix or whatever, it's always gonna be J is always gonna have a minus in front of it, and that's really it. That's the only. This is why this is right here. So then we're gonna go into partial derivative of P, which when I'm using P and M, okay, obviously again you already know this, but this is just more context for like why I'm doing this. If you're watching this for the first time, you don't understand like what the curl of a vector is or what an actual vector is or whatever. When you're looking at the vector, say you have vector A, B, C, you can represent it using so many different letter combinations or whatever. But a common one is M, N, P, comma. And it's just another way to label them. You could replace all these with A, B, C, whatever. But it's just saying the M term, the N term, and the P term. That's literally it. So, and I'll show you examples in a second. But yeah, we're gonna take the partial derivative of the last term, P, with respect to M, which is the first term, and then minus the partial derivative of the first term, M, with respect to the last term, P, and then plus partial derivative of the middle term, N, which is going to be Y, and then with respect to X, the first term. You see I'm switching. Actually, I should have done that here too, but that's how it's supposed to be written. Yeah, so I switch at the bottoms. The bottoms are the ones where it should be the actual variable number variables like x, y, z or whatever. Because again, it's gonna be x, y, z. That's how you're gonna write your functions. It's gonna be like that equals f or whatever. It's just the notation. Literally, it's just all for notation. And then this is minus partial derivative of x or m over or with respect to y. That's the entire formula. And no, it's not bad, right? It's not a bad formula, but it's just a lot to remember, you know. It's something so silly and plain, but it really works. Like an example. But yeah, so yeah, this is the whole thing. This is m and p or x, y, z. This is it. So when you apply the formulas to this, you can find the curl pretty easily. Or at least the formula for the curl, then you can add in your coordinates. So say you want to find the curl at 0, 1, 2, then you would just plug that in or whatever. But I'll show you this first. So if we want to do it like the formula way, this is what this is showing. This is what this is showing is the formula way. So if we want to do it the formula way, I'll switch colors. So then when you do this, you're gonna find literally it's the exact same process as doing the curls with a vector. This is literally just showing you what cool trick I use to be able to remember it, because I don't know, I get lazy whenever I'm doing math and stuff like that. And I'm like, I really want to just get to the answer or find an easier way to do the formulas, because a lot of times the formulas end up merging together and look almost exactly the same except for like one variable. So it's easier to do stuff like this to like differentiate it from other things. Because if you find, like, even I made the mistake when I was thinking about this video, finding the curl of a vector is very similar to figuring out if a vector is conservative or not in terms of like calculation, just how it looks. So this could also work for that, maybe, if you like switch it around or whatever. But yeah, so then you can go ahead and solve this. This is your final answer right there. That's the curl of the vector. But if you want to plug something into that, I mean you can just like see what the curl will be at specific points. You literally just plug that in. So then that would be what, negative 9i minus 49j minus 4k. And do that. So this will be your curl right here. So I mean, this isn't 0, so it's not irrotational. It doesn't have a rotation, but it looks like it's a negative rotation. So yeah, I mean, this is like the, yeah, I didn't know what I didn't know what the answer was. So this is just a random one, a random example. I've never done this one before, but yeah, you can plug any numbers into there, obviously. But it's just something cool. Something cool I found. It works. It's pretty self-explanatory. PNNP, PMMP, NMMN. I mean, that's like the whole thing, right? That's easy to remember for an exam, for a test. You can like make a silly character, a silly shape out of it if you want to make it easier for yourself to remember. But I don't know. Just something I wanted to share. I can make more like an in-depth video about this whole thing, because I think it's pretty cool. Just vectors in general are pretty cool. Like the applications to the real world are pretty cool. So yeah, I don't know. But yeah, just a quick way that I like to remember how to find the curl of a vector. Pretty simple, pretty easy. You don't have to use it if you don't want to. Just thought I'd share because I don't want to keep this to myself, because it's something that really helped me. And yeah, so let me know if you actually use this or not. If you actually use this, if you're going to use this, let me know. Or if I messed up on something, let me know. Or if you're like, oh wait, there's an easier way, let me know too. And also, if you want a video on how to find if a vector is conservative or not, or just the overall idea of curl and divergence and how those ideas relate. I don't know how to end these things. It's so hard to end a video. You just say bye and hi. I don't know. Just